like to welcome you to this inaugural Friedman Forum. I'm Lars Hansen. I'm the research director at the Becker Friedman Institute. And we're very excited to kind of initiate this program whereby undergraduates can get access to the best and brightest scholars within economics. And we hope that tonight's event is one of many that we anticipate doing events like this once a quarter as long as you're interested. So as long as you maintain your interest, we are happy to support this. So the the Becker Friedman Institute is all about kind of supporting research across the board on campus, and this extends all the way to undergraduates in terms of supporting events like this. Many of you know Milton Friedman as the kind of great policy advocate, but Milton Friedman is also a tremendous scholar. I would urge you to read the first few pages or paragraphs, at least, of his Nobel Prize address, in which he makes it very, very clear to do that a precursor to any type of serious policy analysis is kind of the scientific endeavor of kind of documenting modeling the mechanisms by which the policy achieves its goal, documenting it empirically, and kind of approaching economics with kind of complete and great rigor. Milton Friedman himself was a tremendously innovative scholar, much beyond just the policy positions that he so effectively articulated. So tonight we kind of have a great illustration of the type of research that Friedman personified as well, with Professor Jim Heckman. I think it's wonderful that and appropriate that he's kind of our inaugural Friedman Forum presenter and speaker. In fact, he's actually one of my few colleagues that was one of Friedman's colleagues. So he's knew Milton Friedman firsthand as a colleague here at the University of Chicago. So what I would like to do now is to, first of all, thank C.K. Chen, Jin-Soo Han, and Mary Claire Griffin, and turn the program over to them.
Good evening, everyone. So as most of you know already, Professor Heckman is a recipient of the Nobel Prize in Economics. He is also the top 2 economists by the Ideas ranking. But remember, he is also a professor at the University of Chicago, right near us. Though before I met him, I was intimidated by his fame and accomplishments, I soon figured out that he in fact has a warm heart and cares young students and researchers a lot. As a matter of fact, tonight he happily agreed to talk about his ongoing research at the undergraduate brown bag event hosted by the Becker Friedman Institute. So to briefly introduce him, he studied mathematics at Colorado College and earned his PhD at Princeton University. He came to the University of Chicago in 1973, and he is now the Henry Schultz Distinguished Service Professor. He has published hundreds of books, papers, and articles covering an extraordinary range of subjects focused on the study of human inequality. So the Nobel Prize was awarded for Professor Heckman's work in microeconometrics. We all probably heard of his famous Heckman selection model. He is well known for not only for his theoretical work, but for also his empirical research. Among many, his recent research interests are regarding early childhood education programs, human development, and life cycle skill formation. Now I turn the mic to Mary Claire, who will briefly discuss the proceedings of the event. Thank you.
Can everyone hear me? It actually works. Okay. So welcome. During the panel, Jin-Soo and CK and I are going to ask some questions about Professor Heckman's research for the first hour. And while we're talking, we'd like to encourage you to think of questions that you might have yourselves that you would like to ask in the half an hour following that. So I'm going to start our first question, and it's a very large question, so we will just briefly touch upon it. But we were hoping that some of the students in the room are pretty familiar with statistics and might be wondering how what they learn in statistics class is different than the kind of econometrics that Professor Heckman uses. So we would like to start off with just a short discussion of the difference between statistics and econometrics.
So the question is a good question, and I would make the following point. Economists are generally interested in policy questions. not just generally, but almost universally. What happens when you change the world in some way? Kind of question that Lars was talking about in terms of looking at what Friedman was interested in, what most of your teachers here in the department, I'd say virtually all of them, are interested in policy questions. And associated with that is the analysis of what's sometimes called counterfactual analysis. That's what all of this is about, trying to understand counterfactuals. So the kind of counterfactual question would be, suppose that we reduce the income tax rate. How much is that going to stimulate the U.S. economy? How much will it have any effect at all? How much will it affect deficits? How much of it will affect labor supply? And there are a series of other questions like that. Economists build tools to really understand these counterfactual studies, these out of our experience analyses. We have very few examples where we have a policy that we're interested in that's previously been implemented. We always are thinking about new policies, even old policies applied to new situations. And the essence of what economics is about, and a lot of econometrics is about, is building these models of counterfactual analysis and using economic theory coupled with some statistical tools, not even and inventing statistical tools is needed as well, to try to describe and predict future policy changes or current considered policy changes. That involves a completely different activity than just purely descriptive statistics. I think one of the major differences probably is that economists are really thinking about economic models. They're thinking about economic structures. Economists have developed an entire, what you want to call it, lexicon, or a vocabulary, and a set of frameworks for thinking about out of equilibrium analysis. And that's just not part of statistics. I mean, statisticians typically like to analyze data. They model data, but it's typically within sample. It's typically describing a state of affairs as is. And one of the central problems in economics is really to think about the world as it might be, and then to use that in policy analysis. Because any policy analysis is going to be saying, what if I did this versus what if I did this, what if I did that? And that involves a very different kind of framework from just describing the world. It's kind of predicting the world. Huge, huge questions. Very difficult to do sometimes, but actually a very fruitful activity. So I don't know. I could go on for a full hour. I don't think you want me to do that. But I think the structure is, I think it's pretty clear. So it's really that we think about how people choose, how agents interact in markets, how they may interact even not in strict market settings, but in social interactions like this one here. You guys aren't paying each other to be here or interacting, but you are exchanging ideas and so forth. And so it's the modeling of the social interactions, the economic transactions, and then the analysis going from the individual level to the aggregate level and understanding how that's done and how policies change behavior. And many things, like, you can think of hundreds of policies. What happens if you have choice in schools? What happens, I already mentioned the tax policy. Well, what happens if you run a sustained deficit in the U.S. economy? And on and on and on. Those tools are not available as straight statistics. Statisticians don't touch that. I mean, there has been some very fruitful interrelationships over the years where statisticians have understood the kind of problems economists are doing and even developed tools that we've used. But there still is a major difference because it's the application of the tool and even the suggesting of the problem that sort of makes it. So they're, in the healthiest state of affairs, statisticians and economists work together, but there's always a behavioral component to it that many statisticians, I think maybe some of you are stats majors or joint stats and econ majors, wouldn't really be sympathetic with. I mean, there's a lot of sense, that we have these models that sometimes people find difficult to explain. And the reason why it's difficult to understand is it's more than just a formal mathematical model. It's a body of tools, a body of experience, a bottle of a whole set of collection of responses and wisdom about previous models where they failed and where they haven't. And that requires more than just writing down a statistical model. It really requires using economics, looking at the data, and then looking at history and looking at a whole set of other activities than just purely statistical analysis. So, That's too long an answer for it. It's a complex question.
Yeah, so I would like to continue this question by discussing your own econometric model. As Jin-Soo has mentioned just now, Professor Heckman is most famous for his formulation of Heckman correction. It deals with the problem of selection bias from a whole new perspective. It is often described as the landmark of modern econometrics. However, it is very unfortunate that Heckman correction is not part of our undergraduate econometric curriculum. Or should I say fortunate? So, Professor Heckman, would you please help us understand the basics behind Heckman correction? Or for the general audience, what is a selection bias in the first place, and how does Heckman correction deal with the problem?
Okay, well, you might guess, if you haven't already, that some of this is rehearsed. So I am going to go to and use some slides. I have about 400. In case any of you have taken a class with me, you'll know that's a short number. But actually, I did anticipate this. And what I did was I created something on this question about bias. Let me just go through the very simple basics. So basically, everybody knows or thinks they know what a random sample is, right? So, I mean, formally, a random sample is a sample. Say you have some random variable y, and basically you have a sampling scheme where all values of y are equally likely to be sampled. That doesn't mean they're all likely to be realized. Some are more likely than others, but they're all likely to be sampled. Now, in economic models, just sort of building on this previous question, you have a choice problem, and you have a lot of decision rules. I'll only illustrate the simplest because I know you don't want to hear a very elaborate lecture, but I'll give you an example of a biased sample, and it's one that was actually done here, one that showed up in applied work here in economic history, looking at Bob Fogel, who is here at Booth School and also in the economics department, has actually done a lot of work on the economic history of nations, in particular long date time series on the height and weight of individuals in different circumstances. This problem arose in his work. He was actually interested in using the height of British sailors as a measure of what their nutrition was. And one of the most interesting findings from his work was that Marx was right about 150, 160 years ago. Marx said that capitalism was actually screwing people and that people were actually getting getting worse off as a result of the capitalist system. So Fogel said, well, is this true? His way to look at it was the following. Well, there's some sense that this might be true. And the reason is that there was this whole notion of the enclosure movement. You probably read about it. During early stages of British capitalism, there were a lot of people crowded into cities. Wages are relatively low, and there was a whole discussion about poverty. You probably heard about that, Malthus, and so forth and so on. So anyway, to get to the point, that Fogel collected all this data on British sailors. It turned out, though, to try to measure the chart, but it turned out that over time, the rules for being a British sailor changed. If you're too short, you couldn't be a sailor. Just like in certain Air Force situations, if you're too tall, you can't be a pilot. That's kind of a reversion. So this doesn't sound like a choice problem, but I'll get to a choice problem in a minute. So basically, what you would observe in his sample were the heights of people whose height was above some cutoff level, C. C is the cutoff height. And so that's called a truncated sample. That's an instance of this kind of sampling bias problem. So if you draw a normal distribution, there's no reason why it has to be normal, but let's suppose it is, then what you have is a population is out there, but you don't observe the lower tail. You don't have any idea of what's out in the lower tail. You may know the fraction of people who weren't observed, but you don't know what that lower tail is. So this shaded area, the so-called missing region, is just something that the sampling scheme wouldn't give you. This is an example of a biased sample. It's a very simple example. Now, more generally, we can think of this as a part of what's called a weighted distribution. So more generally, we have sampling schemes that sample from different parts of the distribution. So, for example, let me take a discrete distribution example for a minute. Suppose you go say you go downtown to the train station, and you ask people, what's your typical mode of travel? You're in the train station. You might think, correctly, that you'd oversample people who ride the train instead of drive. Just like if you went to a gas station, you'd probably find you oversampled people who drove. Those are all examples of biased samples, where choices actually generated the strata that you actually sample. So a very general characterization, I won't go through it, is basically we have a weight. And we're weighting different parts of the distribution, either because of choices or because some sampling scheme that was put in place. And so if we write, if you remember my notation before, the density was f of little y, and the weight is going to be some number that's non-negative, could be 0, it was in my previous example, that basically just reweights the distribution. So the statistician or the agent, however the weighting occurs, overrepresents some part of the distribution relative to the others. So my previous example was a piece where the weight was either 1 or 0, and you basically cut off the lower tail. But there are more gradual, more continuous versions of this. And again, maybe that's just too much. Tell me when to stop. Basically, if I know the weight, and that's my density, so if you look at this density here, this thing here, if I know the weight, the W of y, and I actually observe the weighted distribution, the G of y, you can kind of see that except for a constant, and this is just a normalizing constant in the denominator, that basically what I can end up with if I know the weight is that I can get the true density up to some, as long as the weight isn't 0, right? I could do the following. So the actual density is G of y, the one that I get from my sampling. The weight is W of y, which I assumed I know, so yeah, by some rule, by some choice mechanism or whatever. And then what I can get is basically the true density by weighting. So that's an example of a selection issue or a sampling bias issue. And then by some just notion about the properties of probability distributions, turns out I can actually get the true density. But that assumes the weight isn't 0. Obviously, if the weight was 0, I couldn't divide by it and I'd have some troubles. But short of that. So basically, this is an example, very common. Let me show you something that shows up in real practical problems. And we're studying the economics of the poor. For example, a very common study is say, I want to study poor people. Okay, I want to look at what are the determinants of earnings of poor people, right? So what I'm going to do is say, okay, here's an earnings function, y equals x beta plus u. Things like ability are in there, motivation, education, work experience, and the like. And this last expression here, x, just means that x is independent of u. Actually, I realize I'm used to that notation so much it never occurred to me. You'd never seen it before, but that's what it means. Okay, so that's a regression. But this isn't just any old regression. This is a regression fit on people who are poor, right? So what I'm going to do is basically say, okay, here is so what I'm going to actually end up with my data is a sample of poor people. Now, what does that have to do? I'm interested in what affects earnings. Say, does schooling affect earnings, okay? So that's going to be the causal effect. Using the notion before, I introduced the counterfactual effect, is what happens when I change x. Suppose that x is schooling, education. What's the effect of a change in x on earnings? Why? That would be a causal effect. Holding constant u. All right? That's a causal effect. I want to get my hands on beta. But the trouble is, what I end up with is a kind of mongrel function that consists of the true relationship plus a bias term. That's the formal term. That's the formal relationship, the true relationship plus the bias term. Now, let me show you a picture. You've all seen regressions, right? You know what a regression is? Most of you? Okay. So I'm going to say my true function so this is from an actual study on the economics of the poor in U.S. data. But without getting into the details, suppose that the true relationship is this thing here. So it's this line that has yi equals g of xi. That's going to be the true regression function. It doesn't have to be linear and not distort. But I'm going to sample people whose incomes are below the poverty level. That's what y sub p is, okay? So think about what that is. So the true regression line, true observations are living somewhere at sampling realization. So you know there are positive residuals and there are negative residuals. So in the population, the true population, we got a hold of it. Basically, the errors, those u's would be distributed kind of symmetrically around the regression line if it was normal, say. It doesn't have to be symmetric, but let's suppose that it is. Now, what happens, though, if I put up this barrier, yp? That means that I'm only going to observe observations, especially if I'm over here close to this boundary line, where, in this case here, I've drawn it in such a way that about half of the observations in the true value, if I start with this value of x, half of them would not be sampled because they're too rich. because they had a high U. Their incomes are too high. So what I'm actually getting is a sampling of people down below this barrier. And as they get closer and closer to the barrier in terms of the X, so here's an extreme case that virtually all these people with a high level of X, only these people are actually going to get their way into the sample, right? And if I go the other direction, way down, let's say low levels of education, say people who are illiterate or have like 1 year of schooling, then they're going to be pretty far away, and there's not going to be much variation, much of the sampling problem. So the shaded area is the included part of the distribution for each part of the potential distribution, and the unshaded area is the fraction that don't make their way into the sample. Okay, just the proportion. So literally the area here is representing. So most of the people here are going to get in. A few people who have a very high value of the residual aren't going to make their way in, right? But over here, virtually everybody is not going to make their way in. Now what happens if I fit a regression on that line? So I want to get my hands. Remember, I'm interested for policy purposes of saying what happens when I change the X. That's the true causal effect, holding U constant, right? The effect of changing X, holding U constant. That's going to be given by this regression line. But now if I fit a linear regression in this sample, I'm going to get this dashed line. It's going to really substantially underestimate the effect of education on earnings. And if I fit a nonlinear function, that's what I'm showing here, it'll kind of asymptote out here, but it's still going to be very badly biased. Now, where is it not going to be biased? When I get way down at the very bottom, right? And the reason why that is true is that virtually everybody here, all the people down here are going to get a very low probability of getting, a very high probability of being included. So as I change the X, I'm getting two things going on, right? The causal effect and the sample composition effect. It's that second term. That was the so-called selection bias term. And now we model that term. So you don't want to get into details of this, but I'll just show you an example. So is this diagram clear? Is it? Okay. Maybe it's too simple. I don't know, but there it is. So basically, we can model a bias. And this whole idea generalizes. And so what's the probability of this event? Well, the probability of the event that the earnings are less than some threshold, I can just, I can basically say, okay, it's that if X is something I observe, that U, those residuals, are living below a certain number. And if that number gets to be, so anyway, and this is going to be just P sub U. So if I go back to the expression I put up a minute ago, what I'm actually estimating in the linear regression case, by just looking at data, just doing a purely statistical analysis, is the effect of this plus the effect of that combined. So it's the effect of X on the causal effect and how X causes U to be more or less likely to be in the sample, which has nothing to do with the policy problem, what happens when I increase the amount of education. So that's the point. So you can model it, and there are a bunch of different ways. There are many richer examples. I've given you the simplest one because you can draw figures very nicely. But there are many more subtle decision rules. So I might only observe people if they, say, respond to a questionnaire. Or I might only observe people if they happen to be living in a certain region, or they happen to be of a certain other kind of status. The whole thing, and this is the point that I was talking about in the first response, is that this probability of selection is something that the economist looks at. It's something that the economist models, what the choice process is. It could be very rich. The reason why I don't observe the earnings might be a non-response. It could be an error on the part of a survey statistician, or it could be a deliberate choice, or it could be a number of other factors why people are actually ending up poor. And it could be not just the simple truncation on earnings. It could be that basically they're defined poor in various other ways. So the more general point, though, is we can think of this as being a function of the true model, which is going to give us the causal relationship, and this bias term. And so we model a bias term. So let's suppose we get way down, low X. Like if I get down way on this scale, down to, let me go back one, if I can here. Wait a minute. Somehow, why is there no up arrow? This is only going, this probably tells me to stop. I can't go back. Oh, here it is. Yeah, it's slightly off. Wait, but it's still not working. Yeah, that's very odd. Well, there we go. Anyway, so basically, if we think about this term, and we think about what's the value of this term way down with a very low value of x, very low level of education, the probability is virtually 1 that you're going to be in the sample. I mean, it's just a fact of life, unfortunately, that high school dropouts, especially those with 8 years of school, say, are going to typically be way below the poverty line. And so basically you can show this term is going to be 0 for those people, which it was. The true line and the fitted line were the same. And then when you get up so that the probability is virtually 0, that was my last example. Just too bad I can't draw this, get this back. I don't know why it won't. Oh, there you go. I was pushing the wrong one. Okay. So this is basically the probability of being sampled close to 1. So the actual probability is this shaded area. It's the area under this density. And it gets worse and worse, the more and more selective sampling. And you control it. You model it and you control for it. So that's the simple idea behind it.
Yeah,
Okay?
and sort of relatedly, Jin-Soo wanted to talk about non-cognitive skills, which are sort of an unobservable in themselves. So
Yes. Okay.
perhaps he could present
Fine.
a question to you about that.
Okay. I will.
So, in your research, you often mention non-cognitive abilities as unobservables. So, what do you mean by non-cognitive abilities, and how does economists measure such subjective variables?
Well, first of all, what do you mean by cognitive ability? I'll turn the question back to you. Well, I mean, we all think we know what it is, right? IQ, grades, something like SAT scores. Those are 3 different measures, by the way, and they're not all that well correlated with each other. IQ, achievement, and grades. Those are all measures of cognition. That's just for openers. So let's say that it has something to do, so the psychologists basically think a lot about what are called crystallized and fluid intelligence. Maybe you've heard about this. Fluid intelligence is your capacity to answer abstract, reasoning relationships. We think of what a pure IQ test is, a Raven's test. You've probably all taken plenty of these tests where you say A is to B, is C is to, and you go through a list of things. Something allegedly very context-free, or an attempt is made to be context-free. Achievement tests actually are slightly different because they're testing not only how fast you can answer the questions, but what you know, right? So we have all these tests, like the PISA scores, if you're from Europe, or SAT, or Armed Forces qualifying tests. There are a bunch of these tests that are designed, say, to monitor schools. How much did you learn? So the Iowa tests of achievement are examples. ACT, number of these tests. And then grades you all know, probably actively pursue them. Those are 3 different measures. And so where does non-cognitive traits come in? Well, first of all, non-cognitive traits turn out to shape answers in virtually all of these measures of cognitive trait. That's one thing. But abstractly, the idea is something other than the purely, quote, cognitive, something that sounds a little circular, and it is, but it'd be aspects of personality, aspects of preference. Like you've all studied time preference, right? The ability to sort of delay gratification, how much you discount future utility as opposed to current utility. You've seen also some notion about time preference, risk aversion, I mean. So how much do I need to actually engage in a risky situation? How much do I have to be compensated? Those are examples of preference parameters, and we think that at least parts of those are generated by something other than just your pure active intelligence. Actually, one of the challenges for economics is thinking, how do you actually model IQ? We all know what it is, but where does IQ enter an economic model? Maybe the real challenge is actually putting IQ in a model. What is IQ? I mean, so many people say, well, time preference actually turns out that people who have higher IQs generally have lower time preference. Why is that? Well, maybe those people with higher IQs are better able to sort of forecast the future. So if you think about a forecasting problem or like granular resolution of pixels on a screen, that maybe these people would be less risk averse. Maybe, but you could also imagine they could imagine all kinds of horrible things, and they would look like they're more risk averse. The fact of the matter is there are a set of traits, risk aversion, labor supply preferences, and so forth. Now, those are traditional preferences that economists have looked at. More recently, ambiguity aversion, how much people really are fearful or really sort of they're uncertain and they don't like new situations. They may not even have a clear way to compute the probability of some event. It's what Lars has worked on, actually, and there's quite a bit of research on this. I mean, this is the nature of a lot of modern economic decision-making problems, right? How averse are you in a situation where you really don't even know the parameters of the economy? Like the world changed in 2008 in certain ways. There's certain new financial instruments emerged around 1999, 2000, and people didn't really know the full parameters of the model. How do different people react to this kind of uncertainty, fundamental uncertainty about the world? It's not something you can take a gamble, and you can't get a bookie to essentially sell you a bet on this or anything. It's really something that maybe is fundamentally not, the odds aren't calculable. There may be some very broad range. So the question is that your preferences, the way you respond to these different situations, we study these, and we have a whole set of new preferences that economists have brought in. Trust, for example. Reciprocity, how people interact with each other. Altruism. Why is it that somebody's altruistic towards somebody else? There are many reasons for that. You might think that you actually genuinely care about the other person, or what I could really care about is how I impress him about my gift to you. I could give a damn about you, but I want to make sure that I am, I'm perceived as a good guy. And so there are a whole series of studies that economists make about with these non-cognitive traits. Even the notion of reciprocity or concept of fairness has been studied, both in laboratory situations and in real-world situations. Now, enter the psychologists. There's a whole series of studies by personality psychologists who also describe even richer categories of behavior than what economists have traditionally looked at. So it includes things like conscientiousness. Even the people who invented the IQ test said the most important single trait in life outside of IQ, which they love, is conscientiousness. And it's very predictive. It turns out conscientious people, those who sort of stay on task, have a greater life expectancy. That's more predictive of life expectancy than IQ. And agreeableness, which is another trait, what a kind of a social animal you are, that actually has a negative effect on school achievement and grades, and on and on and on. There's a whole litany of these traits which have been cataloged by economists, by personality psychologists, and have recently been studied by economists. Now, enter the economists. And I think we entered very actively in a very positive way. Psychologists like to think these traits are there. I don't know how many people have taken courses in psychology or know about psychology, but okay. So you'll see these things. There's a questionnaire. You get, I'm going to survey, are you agreeable or not? I could give you a questionnaire. There are these personality inventories that firms give people, and in fact, the companies that give these, sell these, make money. So there's got to be some market value. But what we really see is that virtually every measurement of these psychological traits by psychologists is a result of the individual performing a certain task under a certain situation with certain incentives. So enter the economics. These psychological measurements have to be carefully constructed. I'll give you an example. Everybody knows about minority-majority differences in IQ. We've been studied. For example, there's been some study that historically one standard deviation difference between African Americans and whites on IQ scores. Maybe it's not less, maybe a little less well known is there's a 2/3 of a standard deviation between Ashkenazi and Sephardic Jews in Israel. There are some very sharp differences across different ethnic groups. But now turns out something very interesting. If you measure IQs and incentivize individuals to do well in an IQ test, the African-American white gap vanishes. If I give kids one M&M for each correct answer in an IQ test, the whole gap goes away, at least on that test. That doesn't mean they're going to eliminate the gap in the future. But what it meant partly is the kids weren't incentivized. And so what economists have done is say, okay, we have these broader measures, but we have to be really careful about the broader measures. And the broader measures are partly a function of incentives, and they're partly a matter of other traits. So it turns out if you get kids who are very high in conscientiousness, and you try to incentivize them, like most of you in the room, I assume, are highly conscientious, and I pay you for an extra point in an IQ test, you're going to get a very flat response because you're already trying your best. For other kids who may not, for cultural reasons, for a number of other reasons, may not be that motivated, paying them makes a big difference. So it's these other traits that matter. And it's not like this is in contrast to what's going on in economics. It just enlarges the set of preference parameters, the set of descriptions we have of behavior that help us predict. But there's a very active and ongoing research area where people are trying to look at the structure of how these psychological parameters, once standardized, are for incentives and situation and the like, how those parameters relate to standard economic parameters. And it turns out they're not that closely related. So it looks like there are extra dimensions of behavior that help us in predicting these kinds of models, help us with a fuller understanding of how differences emerge and how we might do something about those differences. So that's the not so short answer, but an answer. Okay.
Well, in the context of your own research, you've also seen a lot of this with the Perry preschool intervention. And are there any aspects in which the Perry preschool intervention has broadened your own understanding of how non-cognitive skills contribute to different life outcomes?
I don't know how many of you know about this so-called Perry preschool program. It's kind of iconic. It's been very widely studied. We have a whole group working on this now in Chicago. It was a study that was originally executed about 50 years ago. And this study took kids, all of whom were living in one area just west of Detroit, a town called Ypsilanti, Michigan, if anybody's from Ypsilanti. It's also the place where the international headquarters of the International Workers of the World. And it's also the place that where Rosie the Riveter allegedly was working during the Second World War. I think she has multiple sites claim her. But in this site, an experiment was run for disadvantaged kids. By law, and the funding was only available for people whose IQ was 80 or less. These were all kids in the 3 to 4 years of age. So it wasn't a random sample of the population. They could get money from the state of Michigan to study these people if their IQ was less than 80. So they took these kids below 80 IQ. What they did is then they provided an intervention for these kids. And what they did is they provided them with what we now understand would be the names aren't so important, but basically they were taking kids in, and these kids were not all single-parent families, but they were all disadvantaged, generally speaking. All IQ kids are, frequently in that case, not all. But what they did is they took the kids in each day for a few hours a day. They basically took them in and said, okay, today you're going to pick a task, just a task, like build a model, paint a picture, write a poem, something. I guess they weren't writing too many poems, but they're 3 years old. But whatever. I mean, build a model, toy car, put a puzzle together, something. So you pick the task, you do the task, and you collectively review the task. And you work for a period of 2 to 3 days, 2 to 3 hours a day. They did it for 2 years before kids went to kindergarten. So they were randomly assigned a group of people who were in the treatment group and randomly assigned others to be in the control group. And they followed these people. Now they're 50 years old. So we have a lifetime on what happened to these people. Only 2 years were they in the program. The rest of the time, they were just off in their world looking at, they went to their schools, they went back to the same schools, and a lot of the threats to the validity of this kind of study were carefully examined. There didn't seem to be too many challenges along the dimensions of people being singled out. Nobody thought much about these preschool interventions back in 1960 anyway. This is before Head Start. It's like 5 or 6 years before Head Start. So these were a bunch of woolly-headed academics at the University of Michigan who wanted to do this stuff. But they created this curriculum that was essentially heavily loaded towards getting kids to stay on task, to pick tasks. The modern language for this is executive functioning, but there were various other descriptions where people just staying on task, being conscientious, learning to work with each other, resolving their differences. So they followed these kids. There was some cognitive stimulation, but I've been into these classrooms, same curriculum is still there, and basically it's very limited in terms of providing a lot of cognitive stimulation. There are letters around the room and so forth. Okay, so what happened? This was the 1960s. Everybody thought IQ was the end-all and be-all of what a successful program was. In the first few years of the program, and this is something that's found in many studies, the first few years of the program, IQ went up like gangbusters. Remember, the control group had this IQ of everybody had 80 to start with. There was regression to the mean. I could use this picture here to explain why, but put that to the side. Regression to the mean. So the control group mean improved a little bit. It turned out to 85. The treatment group mean jumped to 95 in the IQ test. So it was like a full 50-point difference initially, favoring the treatment group. Did that persist? No. About 5-6 years later, the difference between the treatment and control on IQ vanished. No difference. So by age 10, there's no difference. I know many people said about this program and a bunch of other programs that there was no effect of the program. Didn't raise IQ, and after all, that's all we're about is being smart people. Okay. However, these people were followed for 40, 50 years. We have data on them, experimental data. We analyze it here. Some of these people are analyzing these data, some of these people on this very podium. And there's some very interesting questions we're putting in for data on these people at age 50. There are certain statistical issues. I won't get into that. But what happened was that if you did a cost-benefit analysis, you know what cost-benefit analysis, just ask what's the rate of return? How much for each dollar invested, you get a dollar back? Even taking into account model uncertainty, you got a range of 7 to 10% per annum for each dollar invested. So the program, and what by a benchmark case, at least some people have estimated a comparable number for the stock market between 1945 and the meltdown in 2008, before the latest problem. It was about 5.8%. So you're actually getting a higher return than you were getting in the stock market on average for the average portfolio. Okay. What's going on? If you look at individual treatment parameters, you find considerably reduced crime rates. You find enhanced education for some groups, improved healthy behaviors. It was an IQ as measured. And here's the part that I could show you some slides, but I won't. It turns out that achievement tests, things like the SAT, also depend on things like acquired knowledge. And what does acquired knowledge depend on? How motivated kids are. So it's not just how smart you are, it's how motivated you are to acquire that knowledge. These non-cognitive traits were affected by this program. It actually changed the motivation. So the IQ tests weren't any higher, but the achievement test scores were. And they persisted high. And then you looked at the reduced criminal behavior. You looked at measures of social. Fortunately, we had a whole series of inventories on teacher ratings of these students throughout the school. So it wasn't the trouble is if you ask parents, you ask about subjective measures, about whether kids are good or bad. Most parents love their kids. The little brat will be viewed as a saint by the mother or the father. But the teacher is a little more objective. And using the teacher ratings, which tend to correlate much better with behavior, we found that in these measures of behavior, like how well people stayed on task, getting along with each other, measures of conscientiousness, extroversion, and so forth, that there was substantial improvement on the part of the treatment group compared to the control group. And that carried all the way through into all these life outcomes. So it's almost an argument by elimination. We know they're no smarter. Their achievement tests are a little higher. And if you look at about a third of the variability in achievement tests is actually related to these personality traits for the reasons that I gave. And then on a number of other dimensions of behavior, these kids were performing extremely well. So that's why I think these dimensions, we actually think of this as now, I don't know, I don't want to get too carried away, but there's a non-trivial issue. I can do an experiment, so I get a treatment effect. I can tell you they commit less crime. And that's statistically significant. It survives a whole set of statistical criteria. I can also tell you that their conscientiousness, or whatever trait, let's say conscientiousness, has improved. I have measures of that. That's a causal effect too, right? I look at a treatment effect, I randomly assigned it. Question, could I end up with a statement saying there's a causal effect of conscientiousness on the Perry program outcome? What's the answer? Why not? Exactly. That's the point. So then that's where the econometrics comes in, and that actually goes right back to the point that we had at the very beginning about the difference in the econometric models and statistical models. Because a lot of statisticians, a lot of people actually would say, I'm just going to stop with the treatment effect. Well, we want to understand the mechanism that gave rise to the treatment effect, in this case, conscientiousness. So at that point, you build econometric models, you make various assumptions, you test, can send you a paper if you want. I mean, there's some element of judgment involved, but there almost always is in any kind of interesting inference. You make that explicit, you lay it on the table, and that's how we can infer there actually was a causal effect. And there are other studies as well, the GD and a lot of other studies that suggest strong causal effect of these traits. One of the best examples of these sort was a group of welfare women. We're looking at disadvantaged people. In Canada in the 1990s, a job subsidy was given to kids, to welfare women, young women actually, they weren't kids, young adult women, to go to work. Most of these have been on welfare, just hadn't been working at all. They had very low self-esteem, very little confidence about themselves. They gave these people a subsidy. Some of the same issues are going to arise in the conclusion I'm about to announce, but it's consistent with a lot of other evidence. Namely, these people were induced to go to work. You paid them to go to work. They went to work. It was a subsidy. That's what basic economics would say. Pretty substantial response. Well, what also happened is a result of working and getting into the workplace, their non-cognitive skills improved. A lot of their sense of control of their own lives, the sense of taking care of themselves, the sense that they were no longer wards of the state, and so forth. So you could measure that because you had benchmark measures before they got the subsidy, before the program was even started. You had these benchmark measures. Then these people went to work, and you saw an enhancement in the structure of these non-cognitive traits. That's suggestive, again, but for the same reason, we got to be a little careful, right? But nonetheless, there's a body of evidence of this sort. You can even say, what is the effect of going to college on these non-cognitive skills? And the answer is, there's a substantial effect of going to college, graduating high school. That's a more subtle issue, but you can tease out the effect that's just correlational, that smart kids and more motivated kids go to college, from the effect of college on motivation. And that's the kind of issue that shows up. So there is a lot of evidence of this sort. Probably the last references are a little obscure, but you don't want hundreds of slides on that, I don't think, do you?
So,
no. Okay.
and I think CK has one more question for us before we open up the floor.
Sure. Okay.
So in recent years, Professor Heckman has also crossed into the field of biology and produced excellent works on developmental origins, hypothesis, and epigenetics. So let me briefly explain the terms. For those of you familiar, please bear with me for a moment. So in short, epigenetics studies the changes in genetic expressions that does not involve a change in the genetic sequence itself. And so as we have all learned in core bio, there are a whole lot of processes going in between genetic sequence and the protein products, including transcription, post-transcriptional modification, translation, and post-translational modification, if you still remember. And so any disturbances that occur within any of these processes can have an impact on the genetic expressions without changing the genetic sequence itself. And this belongs to the study of epigenetics. And interestingly, although genetic sequence remain basically constant throughout our lifetime, epigenetics can be changed by postnatal environments and nutrition. And so what is developmental origins hypothesis? It is more commonly known as Barker hypothesis. The hypothesis basically says that nutritional shocks or environmental shocks very early in life, possibly during prenatal stages, can have long-term health consequences. For example, the cardiovascular heart disease at the age of 50s. And so the exact mechanism has not been established at the moment yet, but many scientists believe that epigenetics is at play here. So my question for Professor Heckman is, epigenetics is certainly very exciting in terms of biology, but as an economics student, why should I care about epigenetics? And what does it bring to the table for economists?
Okay, that's a good lecture. I applaud you. Well, okay. So there's always there's always an issue here where you have to separate the cute and the kind of fashionable from something that's actually going to be lasting or important. And there's a danger that some of this phenomena may all just be kind of an interesting biological anomaly. But let me show you a couple of pieces of information why I think it's potentially very important. This is a very new area, and I'm more than happy to send out to people. We have the Jablonka and some of the papers. This literature doesn't go back that far. The major theme that comes out of this, everybody knows about identical twins, right? They have the same, so monozygotic twins exactly have the same DNA, exactly the same DNA. And that's been the basis for a lot of econometric studies, saying I have two identical twins, Therefore, the biology is the same, the heritability is the same, and therefore what it must be is the rest is just experience. Okay? Well, what we've come to understand is that, exactly as CK was saying, that the experience that individuals have in their lives, whether it's nutrition or whether it's some other stimulus, actually will modify the way the genes express themselves. And the way the genes express... So I'll show you an example. And let me show you this one example, which is showing you, I think it's very striking. I don't know how many of you have seen this. There's a paper that was published in the Proceedings of the National Academy of Sciences only about a little more than 6 years ago. And Fraga, Ballestar, and others. What this is looking at pairs along the genome of people, identical twins at 3 years of age and at 50 years of age. And without explaining too much of the detail here, if these were identical twins and the gene expression was the same, the coloration would be the same on the left pair and the right pair. So one is one twin, one is the other. So already by age 3, you can start to see some differential pattern just in the color. I can go into this in greater detail. At age 50, so you've had people living 50 years, they have the same genetic material. The way that the gene expression is turned on or turned off is basically fundamentally different. Look at this site on the gene. So this is a 50-year-old twin. So there are enormous differences. But the question is, so what? Why does this lead to anything? So let me just show you one thing that turns out to be very interesting. A very common finding in the literature has been, in the past, the notion that there was something called the MAOA genotype. And there was a whole literature talking about who commits crime. Okay? So who commits crime? And who commits crime would be people who had high levels of this MAOA activity. But recently, Cassidy and Moffat, in a paper published some 10 years ago, Terry Moffat, and she comes around here a lot, is quite good, and Cassidy does once in a while too, broke out the data in a slightly different way. They said, well, it isn't just this kind of genetic propensity to commit crime. It's whether or not, as children, they were severely maltreated. They have a prospective study. They have records. It's a very comprehensive study where they're actually able to find that the so-called genetic factor only was triggered by an environmental stimulus. It was the interaction. It's actually more than an interaction. It was actually exactly some of the gene expression. But the question is, what's the mechanism? So we actually now turn from humans to monkeys. I know one of the questions that you're not going to ask, but I'll ask for you, is why are we interested in monkeys? Well, we do a lot of drug experiments already on animals, right? In particular, monkeys. They share a lot of the same genes that we do. And so the Rhesus monkey turns out to be something that's quite nice. So a group of us went down to a Rhesus monkey colony in Bethesda, Maryland. It's been around for 50 years. I don't know if anybody's heard of Harlow's monkeys. You know the study? Nobody's heard of Harlow's monkeys? Famous experiment done 50 years ago. I won't. Anyway, these are the successors. A very important paper published about 3 years ago by Meany, Sumi, and Ziff. Sumi is the curator of this colony, and he's a major scientist in his own, was showing that basically 22% of all the genes were affected by putting the monkeys into a form of early adversity. In other words, putting them in poverty. 22%. Now that's kind of interesting. I thought that was extremely interesting. So we went down to sort of check this out. And we went, and we actually then, in some joint work, which is being finished as we speak, with Gabriella Conti, some of you may have taken her course in health economics, and a bioinformatics guy named Steve Cole, and the aforementioned Sumi, tries to investigate the quantitative importance of this. And so the question is, you get a condition of taking the child and putting it in relative isolation, removing the mother. That's all you're doing. You're not starving it, you're not beating it, but you are depriving it of maternal stimulation. There are extreme cases where if you take a kid, put it in an orphanage under extreme situations, you'll actually see the brain development retarded in a way that lasts forever. But this isn't such an extreme thing. Okay, so these people are randomly assigned, these monkeys, are randomly assigned into 3 rearing conditions. Now let me just show you the effects. You can all read a heat map, and so this is what it is. So what we did is these Rhesus monkeys, these macaques, we actually then go through the genome, and we basically are looking at a part of the genome and asking which genes are upregulated, which genes are downregulated. And you see dramatic differences, completely consistent with the Sumi Ziff et al. But again, the question is, who cares? So what? So here are if you're into genetics, these are the various sites. And these are related, actually, to the immune system of the Rhesus monkey. Now you say, well, why do you look at monkeys? Well, we're not going to ask them IQ tests. They're not going to do very well on that. And we probably aren't going to ask what their parents think of them. We're not going to give an inventory of conscientiousness for a monkey. But we can certainly monitor their health. And we have veterinary records. And here's where the econometrics and the economics came in. They'd never done this. They'd never organized the longitudinal data across multiple cohorts of these monkeys. So we said, okay, we know how to do that. And they were amazed. And that's what I'm saying. You should be very grateful for your economics and econometrics training. I can tell you, the primatologist was certainly grateful. So what do we do? This is what we did. So literally, this is a paper that we've just finished, actually with a former undergraduate here, Chris Hansman, who's now a graduate student at Columbia University. And what we found was that, again, you can see the genetic trace. You can see the genetic expression, how different it was in these monkeys. But what we also see, and how there was moderation between the groups. These groups are randomly assigned. These aren't monozygotic twins monkeys, but they are randomly assigned. And you do see differential gene expression. So that's going to be a pretty good surrogate. And then you say, what's the probability of developing an illness, into the early adult years of the monkey? It has a truncated life scale, a compressed life scale, but nonetheless. And you can see substantial differences. For this notion where the mother's taken away and they're reared, you see in lifetime health. Just not that they've been deprived of any nutrition. There is no other thing. In fact, if you visit this group in Bethesda, Maryland, just outside of Bethesda, in Poolesville, Maryland, you will actually see that these pure-reared monkeys actually are suffering from a deficit in non-cognitive traits. They're very shy. You can pick out immediately which ones. The ones who are pure-reared are huddling in the back of the cage. The mother-reared monkeys are up looking at you and trying to play with you and engage you. But they also, it turns out, that the pure-reared monkeys are ones who actually have serious illnesses into adult life. And it's quantitatively non-trivial. Those are statistically significant, and it shows up in the monitoring of the health records. So why am I doing this? Well, because it turns out that poverty actually literally gets under the skin. It literally does. And it actually even changes the way we think about evolution. Everybody's read about Lamarck being a fraud, and what was the name of the Soviet counterpart for Lamarck that Stalin created? Does anybody remember? You happen to remember Stalin's favorite biologist? The idea, the Marxist-Leninist line of circa 1920s was you could modify biology of people through experience. And that was viewed as anathema. Anybody who ever looked at heritability studies circa 1980, 1990, and even 100 years before said that was nonsense. So Lamarckianism was dead. This gives you a form of Lamarckianism. It's not operating through directly modification of the gene, but it's actually modifying the way the gene's expressed. And that turns out to be heritable, and for an obvious reason. Think about it. You change the condition of the monkey. The female monkey will have monkeys of her own and will be carrying the monkey. So there's a direct biological connection. So even though it's not through the DNA, it's through RNA and other mechanisms, you get a form of heritability of adverse experience. And that's been documented now in Argentina. It's been documented in the U.S. And so it's like a new avenue to understand, what is poverty all about? Is poverty just about income? No. Can we reverse it instantly? No. If you really have changed the gene expression, it turns out to be extremely difficult to reverse these patterns. And so we get a much deeper understanding about poverty, inequality, and the sources. So it's quantitatively important. I mean, illness is a huge issue. And so that's why I think I study it. So we moved from people to monkeys, but this carries over directly. We can't experiment, obviously, with people. But we can say the physical organism is similar enough to what we have that at least it's more than suggestive that there's something going on here. And it's another avenue that's completely neglected. Many of you maybe think about going to medical school or maybe think about this. And, in fact, it's true that medical education, very little of these social and economic influences get into the curriculum of a young doctor. They're taught how to treat a disease, not how to prevent the disease from occurring. And so, ironically, economists are coming in basically showing you how it is we might actually change the architecture of the person for the best, for the better, and avoid having long-term illness, maybe thinking of this in a much richer way of policy. So that's a long answer, and I think there are other kinds of illnesses as well, but that's the point. So that's it.
So now, actually, before I open up the floor, I would just like to briefly introduce Jinsu and CK and I and what we do for Professor Heckman, because I forgot to earlier. I'm Mary Claire, and I work on the Chicago Longitudinal Study, which is preschool intervention project, and we struggle with the microphones.
I'm CK, and I have actually worked on this monkey project by running the data. And I've also looked at the Dutch famine and its effect on long-term health consequences.
Hello, I'm Jin Soo-han. I'm a fourth year, and I work on the GED project, which stands for General Educational Development Project.
And if you find any of this particularly interesting and want to think about being a research assistant someday, please do approach us afterwards. We'll talk to you. But anyways, now we would like to open the floor to some questions.
Let me make one remark about the GED, just to explain. It's consistent with what I was saying before. Everybody knows what a GED is, right? I mean, people who drop out of high school take a GED. And what we did is we studied. So it's a test. It's a 7-hour test. You can take the test multiple times. You can pass part of the test. And it turns out that at one time in the history of the GED, you could more or less pass, it seemed, by guessing. I mean, just one answer over guessing. Now, it's gotten better over time. And so it's gotten better, but still something was very odd about the GED. So even though it's gotten better, and it turns out that the GED, this exam that high school dropouts can take, that they're equivalent to high school graduates. The dropouts are then equivalent. And it's treated this way for certain legal purposes and for certain employment purposes, even for admissions in certain academic environments. Colleges and secondary, post-secondary schools, training schools. Now, it turns out these kids are about as smart as ordinary high school graduates. I mean, you look at their test scores, they're more or less the same. What do they earn when they go into the labor market? There's GEDs. Let's just take the GEDs who don't go on to college and the high school students who don't go on to college. Make it simple. There are various versions of this that are more elaborate. Let me just take those. The GEDs who don't go on to college are just as smart as the high school students who don't go on to college. What do they earn? They earn the wages of dropouts. That's the interesting part of it. This is kind of another piece of evidence that these skills, other than purely cognitive skills, matter in shaping the outcomes of these children. And that's why the project is so interesting. It has a number of sides where you can actually document this. And it's a huge problem. I don't know how many people, what would you guess would be the fraction of all high school degrees that are issued to GEDs each year in the U.S.? Anybody know off the top of your head? You guys are not GED material, so you probably don't know. Although there have been some famous GEDs. Bill Cosby was a GED, and the head of Burger King was a GED, and they're famous GEDs. Paris Hilton was a GED. Which kind of proves my point, actually. But no. So anyway, they earn at the wages of dropouts, and so something else is missing. And then it turns out you can follow these people over their whole lifetime with these panel data, and these are the same people who dropped out of school are also the ones much more likely to drop out of a marriage if they get married, much more likely to leave a job if they get a job in the first place, much more likely to drop out of the military than. It's a trait that stays with them. And so this test is a beautiful test. Nobody meant it this way. It's a test of cognition, but it challenges one of the core principles of, I think, modern society about saying we're going to rely on a test score to say who's successful and who isn't. These guys are true losers. 12% of all high school graduates in the U.S. now are GED certified each year. Huge stock. At one time, it was as high as 20%. If you're under No Child Left Behind, you're going to find that a lot of schools will actually route you out of the program and take you a GED. They won't count you as a graduate, but they won't count you as a dropout either. You just get off the books by going to the GED. The GED has actually been put into high schools now. So kids are given the option to take the GED instead of and we know that these kids are not doing that well with it. So it's an important social phenomenon. And by the way, if you look at the if you look at educational achievement of African Americans, how much it's changed over the last 50 years, how many people are dropping out of high school, African American. If you get rid of the fact that there's a disproportionate use of the GED by minorities, and you adjust the fact and count these GEDs as basically dropouts, the high school dropout rate hasn't really changed in 50 years for a lot of minority groups. So this idea that we're getting the secular improvement is just a delusion of a system that says a test is the measure of the person. And it's not. And that's what the project's about. So, sorry, I couldn't resist when you mentioned the GED. I think it's a great subject. And it actually causes us to rethink the social statistics. It causes us to rethink the way we go about it. I mean, literally, you can look at OECD reports today and say, Chile is terrible because its PISA scores are very low. And Korea is very good because its test scores, PISA scores are very high. None of those is getting you a very good measure of the actual non-cognitive traits that also turn out to be so important. Anyway, enough of the lecture. So take questions. We can stop, too.
Yep. Yeah, in case anyone had trouble hearing, Professor Chung just wanted to let you all know that we also are writing BAs if you want to talk about writing economics BAs. Hopefully we'll have inspirational things to say and won't be afraid
And writing
of
published
them.
papers. This paper with Huntsman will be coming out in a journal soon, I think, pretty soon.
Yeah. So if you have a question, if you'd like to walk up to the microphone, you can align yourselves and please don't trample yourselves in excitement to go to the microphone.
I'll be first. Is this on? Okay. So, when an economist is building one of these models, how can he ever be sure that there aren't significant variables that he hasn't accounted for just because they haven't shown up yet? That might come up later. That he'll then find out that the model didn't work because there's something that he hadn't accounted for. It seems like something that you can't know until it happens.
Well, you probably, this is a problem that's more general than just in economics. I mean, David Hume wrote about this, and there's a famous book. One of the images from Hume's treatise on the inference was basically about saying the certain swans, right, black swans, would never exist. They'd never been seen before. And then people went to Australia, and it turned out there were black swans. It's a non-trivial question that you're raising. And it's a huge question for econometric analysis, but it's one that's true across all knowledge. So forget about economics for a second. We think about what the alternative political orders might be. I mean, if we did an empirical analysis to say what's the probability that a third party will emerge in 2012, people are talking about a third party candidate emerging. Well, if you looked at the political variables explaining it, you'd say it's close to zero. And when's the last time we had a major third-party movement? It's been quite a while, actually, unless you count Ross Perot. And there were some studies, but not much. There was, I guess, in the early 90s, but very small phenomenon. The way you can do it is by reasoning, and also by using additional data, and by doing checks. And that's exactly where the econometric approach, I think, adds to it. It's precisely because on a purely predictive approach, if we just fit regressions on what's happened before, we're going to miss a lot. But if we think of using economic theory and social theory more broadly, we can now think about possible counterfactual worlds, right? And in fact, it's not just an activity for economics. I mean, think about space travel. I mean, in 1900, the idea that we would go to the moon or have rocket travel, I mean, there was Jules Verne and there were, these science fiction writers. But they actually provided a very useful stimulus for a lot of work, thinking about what was possible. So this activity of theorizing is extremely valuable because it tells you what within the domain of the plausible, say within the physics, within the known engineering, within the known science, is plausible. We have counterparts to that in economics. We also say, okay, we've experienced various kinds of economic downturns. But on top of that, other than just looking at a purely empirical relationship, we can say, look, I know, and I think I know what the incentives would be in a situation. So you say, okay, look at the third-party candidate situation. You say, well, suppose it turns out that the popularity polls for both President Obama and, say, whoever the Republican nominee, pretty low, say, by early June of 2012. I'm not making a forecast here. I'm just saying, but there are strong incentives to say, well, look, there are these, you have PACs, and they can now produce a lot of money pretty quickly. And so from the pure economics of it, you can start jumping in. You may not get on the ballot in the sense of being on the Republican or Democratic ballot. You won't make the primaries, but still plenty of time to go into the national, right, to register as a candidate, third-party candidate across all 50 states. And so you'd look at the economic incentives, you'd look at what's feasible, and just what's plausible, what the incentives would be. Now, there's more element of speculation there than saying what's the effect of taking an aspirin on a headache. I mean, there's a lot more, but that's the way the world really is. And the world really is all these complexities that are out there. And that's the beauty and the value of theory. It lets us think about what the counterfactual states would be. It lets us imagine. So you get these weirdo theorists, right, who do these strange things. Like they say, okay, we're going to have a currency called the euro. Or we might have I thought that's a good idea, by the way, but they did think about it. Actually, that was developed not in Chicago. I think by the time Mundell, no, he was developed here in Chicago, right? Mundell was on the faculty still at Chicago, so we can claim the euro too. But he said, well, and by the way, the theory in that paper did never apply to Europe. So, I mean, that was well known. I've debated Mundell myself, and he admits it, but only privately. But the fact of the matter is, you could sort of say whether or not what the theory was. There was a theory of the euro. There really was a theory about correlated economies and the value of having a common currency. But there was also a lot of going on, a discussion that went on about the counterfactual states that might accrue. Like, where was the discipline on this? You kind of get rid of monetary policy. Everything's left with fiscal policy. How are you going to coordinate fiscal policies across different parts of Europe? That's what an economic model would do. And there were discussions on that. And then the stupidity of the euro. I don't want to pick on the euro, but it's a good example. That's something way out of experience, right? But people said, what was the mechanism? There was this punishment. If you ran a deficit, the central authority were going to now tax you. You're going to pay an additional bonus. So if you were running already in serious problems, then you'd say, oh, I'm going to punish this economy with additional set of fines and levies and so forth. And again, any economist thinking about incentive compatibility would say, wait, just at a time when economy is down and out, you're going to suddenly say you have to pay an additional, 100 billion euros as punishment for having gone over your budget. And so it didn't have incentive compatibility. That's how the economic model comes in. It thinks these counterfactual states, uses what we know about basic incentives in situations, and then sees. And you kind of could predict that Greece would emerge if you didn't have fiscal discipline and you weren't able to really control so that's, I think, the best protection. Theory and counterfactual thinking, which is what theory really is probably your best protection, as well as a series of empirical checks. So each of these counterfactual theories may give you a prediction on one set of data that may lead to more or less plausibility in the other set. And so it's just the aggregate of the evidence. So there's a whole theory it sounds like a criminal act, but it's called abduction, where you basically, abduction. It's not that I'm literally going to take Mary Claire and kidnap her. It's literally the notion that I build formal models. I have all kinds of statistical evidence. I test hypotheses using the standard rules of statistics. But then I also produce the most plausible explanation for the given set of facts. And then in building those models, I think about a framework if I get a different set of facts. And so it's always so it's the interplay of those two. I could go on, but you can never purely empirically settle that question, right? That I have to think about so what's going to happen with the Martians? Let's suppose we have a nearest planet with the same kind of ecology. The people from this planet come down. We can read some interesting science fiction works and maybe think what would happen. My guess is we're going to be pretty far off the mark on that one. So that's going to really challenge us. But we have some challenges that are a little less demanding, and we do that. So, for example, the multiplier. I don't know how you all know what the multiplier is. Think about the number that was produced early on in the Obama administration. Not by a Chicago economist, I would point out. It was like 1.5. Wasn't that the number? 1.5. And so many economists said, wait, where did that come from? Where's the evidence for this? And right at the outset, people said, no, it's not 1.5. It's Some people even got negative multipliers, but they certainly didn't find 1.5. And they did it by testing different situations, doing different experiments, looking at tight and slack labor markets, looking at and that's the kind of notion where you sort of abduct, if you really kind of put all the facts together and use the theory to kind of integrate the evidence in a way. So that, I think, is that's the only way to protect yourself. But you can never be 100%. See, you're looking for a certainty which won't exist. I mean, it would be nice to know, right, that what's going to happen 10 years from now, because you could insure against it, you could make money on it if you're the only one who knew it. But the fact of the matter is that uncertainty and this other notion of ambiguity, where we really don't even know the parameters we're going to be facing, those are important parts of life. And then, like Lars has done this important work with Sargent, and looking at exactly this question about how do you make economic decisions when you're not even sure about the structure of the economy? And that leads to a different kind of economic decision making. It's not like I'm going to run a regression and say, here's my multiplier 1.5. If you had applied the Hansen-Sargent methods, I think you probably would have guessed that the multiplier would be all over the map, and you'd be a lot less confident that certain kind of stimulus programs would have had the effect that people thought they would if you thought the multiplier was 1.5. So that's the protection people have, I think, the only protection, but no certainties in life.
I read an interview several years ago in which you were commenting on Steve Levitt's book, Freakonomics, and you said something to the effect of, sorry if I don't get the quote exactly right, but you said something to the effect of, it's an exercise in triviality. Could you explain what you mean by that and how
self-explanatory, isn't it?
Then could you explain how you see your research program as accomplishing something different than what Steve's research program aims to accomplish?
Okay, this is what I would say. I don't want to. I mean, maybe that was taken a little out of strong, but I probably have said something like that, so I probably will own it. What I mean is that there are some really big questions in economics. They're huge questions, and they're questions like how the economy develops, why people are poor, what we can do about poverty. These are big questions, and they require really substantial answers. So finding just something that's kind of cute but counterintuitive and doesn't hold up, I think is fundamentally different research agenda than somebody like Fogel, who spends his life understanding what I told you about the height of British people and the fact that the Industrial Revolution, Marx was right, at least during a period. The height of British people, once you corrected for the heels of the sailors and all of that, and the height biases and so forth and so on, really went down. So I don't want to attack Levitt. Levitt's done some very important work. But I would say, I'll give you an example. I think there is a very non-trivial issue about how do you reduce crime. Crime is an important question. Did abortion reduce crime? That's a non-trivial question. That's part of the book. I'll just use that. I'll pick on that. It's been very well studied, and it has no effect. In fact, it never had an effect in many countries when the original article was written. If you looked at Italy, if you looked at England, for example, you would find just the opposite relationship. That crime went up. I mean, if you just do the same methods and so forth. So I would say one should be a little more cautious. Imagine sort of the bigger question. Now, there are whole books written about why the crime rate actually declined. It has declined. It's still a mystery. So sociologists, economists, most serious people. So I would just say triviality may be too strong. It was provocative, it was interesting, it was stimulating. But I think you want to actually consider the bigger question about what causes the economics of crime, and we still don't know. But I think it's important to know what we don't know and to try to look at, it's an open question. Why did so much crime decline? So I think there's a difference. Now, here's another example. I don't know if it was in the book, but there are more prostitutes walking the street in June than there are in January in Chicago. Okay, I mean, that's enough. Well, that's one of the themes. Or that parenting doesn't matter. And I can compare Roland Fryer with Jeffrey Dahmer. Jeffrey Dahmer had good parents, and Roland Fryer didn't. Although actually he did. He had better parents than alleged. But the point is, you're not going to stop with 2. You don't want a sample size of 2. So I can show you Perry, which is a way of surrogate parenting, or hundreds of studies that actually have tried to supplement parenting. So you don't just stop. There's a journalistic level and there is a serious academic level. That's what I guess the distinction. So triviality may be the wrong word. It's more like, there's a gut impulse answer, and then there's a more nuanced answer. Most of you guys, I think, are into the nuanced answers. But I think it's dangerous, actually, to make policy on something that's a gut impulse. The trouble is you see that every day in the New York Times. A guy will look at a correlation, right, and say, that's it. That's the answer. I got to do it. And, the problem with that is that a lot of those correlations fade. It's a little like epidemiology. You read in the day that you drink orange juice and that reduces cancer. And the next month, you drink orange juice and that increases cancer. Why is that unstable? Because it's a bunch of correlations. So you're right. It's probably harsh for a colleague, but Chicago is always a very harsh place. You guys know that firsthand, and people give it and they take it on both sides. So that's part of the ethos of the place. But I do think, and so if you look, Milton was what he was talking about. What did Milton Friedman do? Milton Friedman said, the thing he liked about Chicago most was not that his colleagues, one of the things he liked most is not that his colleagues were trying to get their name in the paper that day or just make a splash. What they were trying to do was really think they were going to really understand the big questions about the economy. So what did Friedman do? One of his most important studies is this consumption function study, where he was looking at the Keynesian multipliers, as a matter of fact. It had implications for that. But it took literally years of work. This wasn't a quick data run. This was actually, and in fact, he didn't, there's a whole, you should read the book. It's a classic study. But what it was putting together these studies and understanding one by one by one and just saying, okay, this study finds that, this study finds that. The findings weren't all the same. What model, what organizing evidence would explain all this body of data? And in the end, he wrote the book, and it's a classic because he did confront all the data. So that's what I mean. I consider that non-trivial. He went off for years doing that work, and Fogel and Becker and many of the people working. So it's a big question. I think that's the question. The economics, this is a serious business, and we have serious problems. So it's good. We have, what's the name of the guy who does the comics? There's a guy who does, I've forgotten his name. He does jokes about economists. Yes, right. So it's fun. It is fun. It's relaxing. But on the other hand, in the end, we're doing more. I think what we're doing is something pretty serious. So I guess that's what I meant. So I'm getting carried away. And you're absolutely interesting point, and probably said it and probably shouldn't have, but I did. So. Okay. No, but I just think that, especially now when we have so many serious problems, this is not a time for joking. Maybe I'm too somber. Everybody should joke. You should lighten up. But in the end, when you think you're doing your economics, it's not a question of just trying to get a paper published in a journal or getting a newspaper reporter to listen to you that day or maybe that year. It's really to understand, what's going on with poverty and what's going on with the economy and what's going on with trade and what's going on with development in China and on and on and on. These are all interesting questions. And these are the kind of questions that I hope you're all working on, at least most of you. It's what we need to know, right? So, okay, good.
My question.
Oh, I was just going to say, I think we have time for one more question. So congratulations on being the lucky winner.
My question actually easily flows into what you were just saying. I was wondering what makes a topic interesting for you, and how do you refine your interests into research questions?
Well, the question of how you develop an interest is an interesting question indeed. No, it is. And, you can't, I don't think there's any one, but I'll tell you what it is. And I think I would advise this of anybody, that many of you are thinking probably about doing graduate work or doing some post-collegiate, post-BA kind of activity. And I think that there are different ways to think about how to live your life. And at least if it's an academic life, it can be very painful to work on things unless you're really interested in it. And if you're not interested, if you are interested, it doesn't seem like work. And so there's a sense in which if you really get interested, so I've actually been very interested for many years on things like poverty, discrimination, inequality. To me, and we have this whole network now studying inequality. So studying inequality, the sources of inequality, racial disparity, understanding these have just made very interesting for me. And then it naturally leads to a series of questions. But then getting back to this question of doing it in a disciplined way, my first impulses were to look at correlations and say, okay, how do you stop poverty? I mean, I'm old enough to remember the war on poverty. I was a graduate student during that time. And so everybody said, we stop poverty by giving people income. And if we give, that's correct, by the way, you do stop poverty, you give people income. But now the other notion was, I give people income, and that's going to make the next generation better off. And that's going to solve the problems down the line. Well, it turned out that didn't turn out to be true. We gave people income. We did it in such a way that we created individuals. We actually seemed to be perpetuating the problem. And what happened was we began to have a deeper understanding of what poverty was, what caused poverty, how we could alleviate poverty. Would raising education do the trick? Just giving people more schooling? Well, not necessarily. There were other factors as well. How important was the family? So in investigating these questions, you are led to a series of other questions. That's just the way it is. And so if you start with these initial questions and you're a little bit honest and try to demonstrate to good colleagues and to the rest of the world and to yourself, ultimately probably the hardest standard, right? You have doubts and suspicions. To try to really understand something beyond a shadow of a doubt or to feel strongly about something, you would actually go through a lot of things, sometimes very painful things, but with a very exhilarating aspect that if you do find some answer, however little simple answer, that helps advance things, you feel very happy about yourself. And there's always, I'm sure you've all had this experience where you have a problem you don't understand, you work on it for a while, and then you have this sense of mastery. Aha! And if you can do that professionally, that's great. So I happen to like doing those things. It's very unpleasant, too, when you have your colleagues and you're correctly telling you that what you've done is completely wrong or nuts. But the reward is the other side, that if it makes a difference, I don't mean just, get on the front page, but I mean really understand something deeper. There's a kind of internal sense of satisfaction that comes with it. But that's more of a scholarly appeal. So I happen to be interested in these ideas and trying to put them together. But it involves a lot of different traits. So I didn't answer your question. I don't know if I really can in terms of interest. But somehow if something grabs you, then you should probably follow it, right? I mean, it's kind of the right instinct. If something really interests you, no matter what it is, you should probably do it. I mean, if you can make a lot of money, maybe you can, but you see all these stories about people who made a fortune and then at age 40 retired and went to something they really wanted to do. So maybe that's another pattern, to self-finance your own true interest. But I don't know. I think it's very useful to pursue your own interest, and these happen to be social questions. I was kind of born a child of the 60s, and there were all these questions that arose, and I still think they're open, but we know a lot more about it. So, for example, we know a lot more about what perpetuates intergenerational poverty than we did 50 years ago. And we changed the policies differently. It's not just a question of giving people money. It's a question about giving people, not giving people, but kind of building in people traits, skills, and attachment to the larger society. I think that's what we learned in 50 years. And I think that was kind of a nice lesson to learn. That lesson wasn't due to me, or maybe little pieces of it were, but it's that kind of thing that I think is extremely important, to kind of ask a big question and then see it to some conclusion. Is that? What's what? No, what was the second hand? Oh, that's a huge. Well, you do what you can, right? I mean, people have different strengths. So, look, there's some people, almost all of these problems and sort of building models require a certain kind of formal structure. Some people are better or worse than building those formal structures. Others are better or worse at collecting and interpreting imaginative data. And so, this principle of comparative advantage applies to research as well as to international trade. And I think that you sort of, people all learn the hard way. I mean, so I could say I really want to understand the gas around Mars. It's not something I'm going to be able to do, and probably most of you won't be able to do unless you land an explorer on Mars or something. So what you do say is work on something that's feasible, but you work on it for a while. So you give yourself the opportunity to fail, and then you creatively learn from your failures. Some people never learn to quit, and that's probably too much of a good thing. But I think it's a matter of doing some experimentation. So challenge yourself. See what you're good at. And then also what really gets you excited. If it gets you excited, then, and you can do it. I think if you do something really poorly, in the end, the excitement will die, right? If everybody's abusing you and saying, you idiot, this is a wrong model, I mean, eventually you're going to be dissuaded. But you should run the risk of being told you're an idiot. Almost everybody in this room and almost every famous economist. There's a great story about Gary Becker. I can't help about this story of experimentation. Gary Becker went to Princeton in the late 40s, early 50s. And his goal, late 40s, he went there to be a mathematician because he thought he was a pretty good mathematician. Turned out that his roommate at Princeton was a guy named John Milner. I don't know if any of you know topology and so forth, but Milner's a very famous topologist, still alive today. And Becker was there, his roommate was Milner. So Becker thought, I'm a pretty hotshot mathematician. Then suddenly he's dealing with Milner, who's running circles around Becker, which he wasn't used to having run around. And so he starts thinking, well, maybe I'm really not a very good mathematician after all, and settle for being a really great world-class economist. I mean, this is the way it always is, right? So, no. I mean, but look, I mean, who was it? There was this there are examples like this all over. So who is this guy? Is it Born? Lars, the guy who was an assistant in Germany to Hilbert, a very famous mathematician. He wanted to be a mathematician. It was Born, wasn't it? It was Born. And so Born was a brilliant RA for Hilbert. Hilbert was this very exacting hair doctor professor type, very famous in the world. But the trouble is, so he did this great stuff. And then Born one day said, I'm actually going to have to do original mathematics. And he hit the wall. So he then decided he wouldn't do mathematics. He would do physics instead. He won the Nobel Prize for his work in physics, but he found out by experimentation what he was good at and what was bad at. So I would just say the lesson with Born, with Becker, and a lot of people is, look, you can be extremely bright. There are a lot of things that are out there you could do, and you need to experiment, which means you also have to take the risk of failure. So Born didn't say, I'm a loser. He went off and actually investigated work. I think he was a co-author of uncertainty principle, and then did some work in later work in physics. And so the point is that you got to be able to take risks. That's the other part of it, and that's how you find out what you're good at. And that's what I would do. You say, I'm really interested in this problem. And then maybe in the end you say, I'm really interested in this problem, but I can't possibly solve this problem. Better to know that sooner rather than later. But some people find it very late in life, too. They've worked on a problem their whole lives, and they, think of what was it, Russell or Whitehead, right? They were going to write the Principia. They were going to do the foundations of mathematical logic. And then suddenly, this guy Gödel came along and said, these kinds of decidability issues you can't settle. What your agenda was a waste of time. They didn't know that when they started doing their book on the foundations of mathematics. But that's just an example. So you had some very bright people. Russell still had a very active life, and Whitehead became a philosopher and so forth and so on. But there really is a sense in which you have to be able to fail and then learn from the failure and then be resilient. That's the other part of it. So take risks, do a lot of things, and then this sounds like homilies, but it's true. And virtually every one of these people has failed at something really deep and important, something that really mattered, and then they bounced back and they said, okay, I'm going to do something I can do well. So that's part of it. Part of the satisfaction, I think, is doing something well, right? So you get a pride of yourself, and I think it's that, but that would just come from trying lots of things. That's why you're here at the University of Chicago, I guess, right? You're trying lots of things. And some of you are trying economics. Maybe some of you are great at it. Maybe some of you aren't so good. And there's a big world out there to do things. Is that the second hit? Okay. I'm talking too much.
Just a quick add-on. So I think Professor Becker's roommate actually went on to get a Fields Medal later. So I think Professor Becker actually picked a wrong reference point.
Well, but it's not clear. He became a great economist. It's lucky for us, put it that way, that Milner was his roommate. He might have not been the same quality mathematician that he is economist. And he certainly knows a lot of mathematics. It's just it's just this question of experimenting with life and seeing what you can do and what you can't do, and then just following your interest and your abilities. Very complex process. Okay.